presentation from folks from HEC. In particular, we've got Chris Dunn, who's the director of the HEC, leading a staff of 50 personnel consisting primarily of hydrologic engineers, economists, computer scientists, and so forth, and oversees an annual budget of approximately $15 million. HEC's program focuses on hydrologic and hydraulic engineering, water management, and planning analysis, and encompasses research, software development, special projects, training, technology transfer, and technical assistance to USACE field offices, as well as other agencies and across the nation, and private and public industry as well. Mr. Dunn holds a BS and an MS in civil engineering from the Pennsylvania State University, and is a registered professional engineer in Oregon. He's a member of ASCE and is a diplomate of the American Academy of Water Resource Engineers. So welcome, Chris. Also with Chris today is Mr. Thomas Brower. Tom is a member of HEC as well, and specifically he is in the Hydrology and Hydraulics Technology Division, currently serving as the lead developer for the HEC's hydrologic modeling system, HEC-HMS. So in this role, Tom oversees all code activities undertaken by the HMS team. Tom architects new portions of code, manages code submissions from a team of developers, and mentors new developers in the code base. In addition, Tom oversees the delivery of new releases to the field. He holds a BS and an MS in civil engineering from the University of Florida and is a registered professional engineer in the state of California. So the presentation topic today is going to be HEC new releases and new approaches. So without further ado, I will turn the presentation over to Tom and Chris.
Okay, well, thanks, Sean. Good morning or good afternoon, everyone. This is Chris, and I can't tell you how excited I am to be making this presentation. There's a lot of really cool stuff going on at HEC, and I also know that some people have some questions about some of the things that we're doing at HEC. Okay. So I wanted to use this opportunity to highlight some of that, and we can't possibly go into all the details of all the software. So this presentation is just really to whet your appetite for future presentations that the HEC software leads will go into more depth down the road. Also, before we talk about the new features, we also want to introduce you to a significant paradigm shift in the way HEC is conducting business. We're going to start by introducing some fundamental systemic changes that HEC is making to produce better products and provide them more quickly to you. Our presentation will attempt to cover two topics. First, we will discuss the HEC's transition to a modern software development and operations environment, and then talk about why that's important to you, and then we'll also highlight some of the new features. So with that, our software development mission has always been to bring state-of-the-art technologies into state-of-the practice by finding or creating new technologies, bringing those technologies into your hands, the hands of the water resources professional. However, the last major software modernization was initiated at HEC over 20 years ago, with software moving from a kind of a Fortran-based code to a Windows environment. And while that was a big step forward with tremendous benefits, certainly for our users, but now HEC is attempting a similarly large leap by pursuing a development to operations or DEVOPS approach. So our goal really is, and always has been, to make our tools more intuitive for you to use, make them faster, make them more automated by providing GIS features directly into the software rather than having to go out and doing GIS calculations and those types of things. We want to improve the graphics. We obviously want to make them more stable and familiar so that they work better for you and that you understand what you're doing. We want to make them more robust, meaning that they can be used over more user cases, and better diagnostics. So if something were to fail, it doesn't blow you out of the water and you have to restart your model all from scratch and those types of things. And also, if it fails, it tells you where it fails, and so we can figure out how to go in and fix it faster. And then all the while, we want to put these tools into your hands more quickly. So that's really the goal, has been the goal. But in order to do that better, we've converted over to what we call this DevOps approach. And so over the last year or so, HEC has invested in and is implementing this continuous integration, continuous delivery software development approach. In order to change the HEC software development culture, we actually bought that book that you see there in the upper right-hand corner, DevOps Handbook, for everybody at HEC, and developed little book clubs so everybody would read the book and talk about the book and how to implement the book. It was written by Gene Kim and a number of other folks, but our goal really was to have HEC work towards a common goal that would enable us to have a fast flow of planned work into production. So we weren't so haphazard in what we were doing and random in what we were doing, but have the planned work into production while achieving world-class stability, so our software works well, reliability, availability, and importantly, security in this day and age with the G6 and ACIT and all their security rules. Our software has to be secure as well. So we're looking to change the way we work with one another at HEC. We're looking to change the way we test software, review products, provide documentation, and increase the frequency of our software deployment. One of the kind of motivational things that got us started on all this was this quote by Eric Shinseki, retired U.S. Army General and former U.S. Secretary of Veteran Affairs, said that if you dislike change, you'll dislike irrelevance even more. And we certainly don't want the HEC suite of software to become irrelevant. So within the book, there's many great quotes. A few stuck with us and really challenged us. One of them is there at the top of the page. Define a measurable goal with a clearly defined deadline. It should require considerable effort, but still be achievable. And it has to create obvious value to the organization as a whole and to our customer base. And so we wanted to be more than just a book club, say, hey, let's read this really cool book and talk about it. We actually wanted to implement it. And so we set a goal at HEC that we want to move to this DevOps environment within 2 years. We felt like that was a measurable goal. It was clearly defined. It's going to require considerable effort, but still be achievable, and it's going to provide great value to you all. And so along the way, we have to have kind of this razor-sharp focus because, quote, like every new application is like a free puppy. It's not the upfront capital costs that kill you. It's the ongoing maintenance and support. So we have to be mindful about reaching out to every new shiny object that's out there. And so we started down this CICD journey. And kind of to talk a little bit more in detail about the journey, Tom's going to take over for a little while, and then I'll come back in a little bit. So Tom, it's yours.
All right. Thank you, Chris. So like Chris said, I'll talk a little bit about what I call the CICD journey, and I'll define those terms, what CICD is. It's a kind of part of what Chris was talking about, being DevOps. We'll talk about that in a bit, but first I'll start a little bit on my journey towards CICD and DevOps, and then the journey that the center's taking. So this picture is actually from my trip. I was traveling from Galveston, where I was a DA intern, to HEC 6 years ago. So I thought it was a fitting picture to capture the concept of a journey. When I showed up at HEC 6 years ago, I was a junior. I started as a junior member of the HEC-HMS team. And one of the things I noticed immediately, so I guess I'll say when you're a junior member of the HEC-HMS team, one of the first things you do is you answer tech support. And so one of the things that I noticed in answering tech support is often I would be telling people about a feature that was, on its way, or a bug fix that had just been implemented. And seeing that when I was telling people, hey, that bug fix has been implemented in the code, but the time to actually get it to them through a formal release was on the order of months to a year plus. And so I was noticing that inefficiency just as a junior developer. And then as time passed, I started asking questions, can we do better? Can we get back to our customers sooner? I was seeing features that had been promised that they were spending a long time in the queue, taking a long time to deliver to customers. So seeing that, it just naturally raised the questions of what can we do to be more efficient and to deliver new features and bug fixes faster to customers. And part of my personal journey was just investigating, hey, what does industry do? There's this whole Silicon Valley thing not too far away from us, and not that I went to go visit any of those companies, which would have been cool, but just reading a little bit about, modern software delivery and deployment approaches kind of helped lead me on this path. And I'll say I wasn't the only one having these questions. I think once I noticed these things and started talking to other coworkers and the other technical folks around the center, it was clear that this was pretty common all around the center, a common question and a common goal to try and change this or make it better. So I'll say when I first started the build process, so actually compiling and building and packaging HEC-HMS was localized to one developer on one machine, and it was rather burdensome. So we would make some code changes just internally and go to test them or fix them, and that would take some amount of time and frustration just to get a build done. Testing the software was very time-consuming. With HMS, we had a full suite of what we call benchmark tests, so just HMS projects that we actually run the software on to test them, and it was a very, I would call it semi-automated, pretty manual, really, the testing as it stood back then. It took upwards of a couple days to actually run through all those tests. And whenever bug fixes and new releases were made, it wouldn't be until a full 1 to 2 year development cycle was released before the field got to realize, these new features. So that's where things were, and then let's step into CICD. We'll start with some definitions. So what is CI? Continuous integration. It's the process of automating the build and testing the code every time a team member commits changes to version control. It encourages developers to share their code because each time they're checking in their code, the code is being tested in an automated way. It's being built and tested in an automated way. And you get quick feedback. So I'll direct your attention to the little graphic down at the bottom. We see the series of builds, and the green indicating a completed successful build, the red indicating something failed in the build. And so we actually have this now. We have a dashboard where if any developer on the team commits code changes, it triggers an automated build and test on a build server. And we get feedback that looks very similar to this that tells us whether everything succeeded and the build is good or something failed. So as soon as the developers committed their code changes, we're getting feedback and can go in and fix those changes. So that's continuous integration. Let's talk about the CD piece. So CD can be two different things. They're very similar. It's continuous delivery, continuous deployment, and the only real difference, so you see the continuous integration piece in the blue box there. We're building our software automated. We're testing our software in an automated way. It's the deployment piece, whether that's automated or manual. At HEC, most of our software is desktop software, and so usually what happens is the build will finish on our build server, and then we'll manually post it to the website. But recently we have a lot of our libraries or subcomponents of our bigger pieces of software. We're actually automatically pushing those to a server called Nexus that applications can pull in. So we're doing some amount of continuous delivery CD and some amount of continuous deployment CD. One thing, I know Chris will touch on it a bit, but I don't know if you've noticed, but most of our documentation has actually gone to web-based now. With the HMS team, we moved all of our documentation to Confluence about a year ago, and that's actually a form of continuous deployment. So whenever someone comes in and says, hey, I think there's a typo on this page of your user's manual, we can go in right away, make a change, and push that change to the web, so it's automatically deployed. So that's just an example of continuous deployment. All right, this is just another way of looking at everything I just explained, and if I explained that kind of fast, let's slow down and take a look here, and I'll try and explain how this actually works. The real novelty of what we've done is the kind of the middle upper part of this diagram where you see the arrows, compile, build, test. So the novelty is that that has all been automated on what I was referring to earlier as a build server. So we have a dedicated server that does these builds, which is really nice in the sense that this is a clean testing environment. It eliminates the case where one developer might experience, the software runs on their machine and then a different developer tries to do something and it doesn't, which was actually quite common before we went to the build server. The build server is kind of like a isolated testing environment, which is really helpful for cornering bugs or inconsistencies. But anyway, so there's the building part that's on the build server, and then we're also running automated tests on the build server. And the workflow usually starts at the developer. I mean, you could expand it all the way out to, okay, here's the series of requirements or the field needs this, that, or the other, but ultimately it's going to come to the developer. They're going to develop a new feature, and they're going to commit it from their machine. They're going to commit it to a source code repository, which is sitting there just above the developer. That automatically triggers this compile, build, test process on the build server. And like I said, this part is the novel part. It's going to automatically compile and then build and then test the software. And if there's errors, the developer gets feedback immediately. The build server will indicate that. And so there's that feedback loop there that's come way down in size. It's now much quicker to detect errors. And they might make some changes to fix those errors, send it back to the build server, and then hopefully everything checks out. If everything does check out, we have an internal in-house manual testing, and sometimes that's, I would say, more formal, and then other times it's just in the form of maybe one of our team members are working on a project with the latest build, and they notice some error. So that gives us another opportunity for a feedback loop. You can see the arrow at the bottom of the diagram coming back to the developer. Hey, this passed all our automated tests, but then something failed in manual testing. So there's that feedback loop. And then if everything passes at the manual testing level, I would call it like the kind of the QA/QC level, then what we're doing is we're sending it out to the field for a beta. And that, I don't have an arrow shown here, but that has its own feedback loop. So it goes out to the field in the form of a beta. They might find something there, and it comes back for more examination. And then finally, once everything checks out and feels pretty solid, then we usually go to release. So that's the diagram. Let's just take a look at this automated building, automated testing curve. And I would say, without getting into the terms, this is just a classic break-even point type scenario. So you can see that manual testing or manual building, you could replace testing with building there. It's going to be a little cheaper up front just to do things manually, get something out the door, call it good. But in software, you never test things once. It's 2 weeks later, 2 years later, somebody's asking for some feature or some bug fix that touches some piece of code that you've already developed and could potentially break it. It often does. And when you go in and make that change that touches some older piece of code, do you remember all those manual tests that you did to initially get it out the door? Most likely not. So it's pretty common to break things in that scenario. So what this is emphasizing is automated testing and how it can save you time in the long run, because if you write tests initially to cover all of the cases in your code, then when you touch it 2 years later, writing a similar piece of code or a parallel piece of code, then you already have tests in place to test its functionality and make sure it works. So as it's shown in the diagram, the initial investment, it does cost a little bit more up front, but it will save you time in the long run. So that's what we're realizing here. I'd say most of the HEC teams did some amount of semi-automated, manual to semi-automated testing. And as Chris kind of alluded to, we're all been coming back around to that steep part of the initial investment curve, because we see the value in CICD and we see the value in investment. So a lot of the teams, I know HEC-HMS went through this the better part of the past 2 years, is standing up all of our automated building and all of our automated testing. And while it's a lot of work in the moment, I'll say it's already paying dividends. So we're already on that part of the curve where we're underneath manual testing, saving time and money. Let's look at this from a project management perspective. So in the traditional waterfall approach, what we would do is we'd pretty much start with a release and say, like, for just example's sake, HMS is on its 4.9 release right now. So we would start with that release and define everything that's going to be in this release. And it wasn't released to the field until everything was implemented and done. And so the new project management approach, because our code is in this continuously testable, continuously deployable state, is to look at the features and rank and sort them, prioritize them. So say, okay, what does a customer have a timeline on, or what's most pressing for, say, the water management community? What do they need immediately? So we rank and sort the features, and then we take them on one by one. And so we can go through the list, the priority ranking, define, build, and release each feature incrementally. And so what that allows us to do is be more agile, be more responsive to the field, and deliver value in incremental steps rather than at the end of a 1 or 2 year development cycle. Now we're developing a feature over the course of 3 months or so and some bug fixes, and then getting a release out, and then going back to that priority list, taking a look at it, picking the next features, going after them, releasing them. All right, this is the ground truthing slides. I've talked about all these great benefits of CICD. Here's just some numbers to put to it, what we experienced as we went through this process with the HMS team. And these are, I'll talk about the process, the duration it took previously, and then the duration it takes today. So compiling and building used to take hours to days and a lot of frustration. And now that's done automated on the build server in about 5 minutes. Unit test, you'll see the previous duration just has a dash there. We didn't actually do what's quite like by definition unit testing in the software. That's been a new part of our software development, is actually unit testing new features. And so we went from no unit testing to several minutes to do unit tests, which is really good. That has helped tremendously. I'll say all of the new GIS code that the HMS team has added is tested in a unit test framework, and it has made my life a lot easier because when I change something or add a new feature, I can run all those tests and have confidence that things are going out in a good state. The validation tests, these are our big benchmarks that I talked about that were kind of our classical semi-automated way to test. Those would take days to weeks to run through, and now we have that entire suite of tests automated, and it takes about 20 minutes. So when I see that full suite of tests pass, I have pretty high confidence sending out a new release to the field because I know it's passed our full suite of benchmark tests. Okay, the cycle for an internal bug fix, build the software and test, used to be days to weeks because the compile and build was also part of that process. Now that's minutes to hours. So if one of the team members finds a bug, somebody can fix it and turn around to build to them in minutes to hours and say, hey, I fixed that bug, check it out. Externally, if the users in the field find a bug, that used to take months to years because that was wrapped up in a full release. Well, now when a user from any office comes in with a bug, it's often we can sit down, diagnose the issue, and have a fix within minutes to hours, and maybe within a day to a week, we can get back to that user and say, hey, test the latest beta. We have a fix in place. We've done some patch releases. These are just bug fixes to some release that's gone out, and that used to not be, it would go out sparingly, but we've been employing that more and more just because we can. It's like, hey, let's fix this set of bugs that, depending on how severe they are, and get a patch fix out. And then releases were something that would take 1+ years that are now, we're doing releases within months with new features. So this is a quote from the DevOps handbook. After all these constraints have been broken, speaking of the building and the time it takes to build and test, our constraint will likely be development or product owners. When the constraint is here, we are limited only by the number of good business hypotheses we create and our ability to develop the code necessary to test these hypotheses with real customers. So what this quote is really saying is that the limiting factor for us is no longer these kind of technical details of building and testing the software. Now the limit is just on us and our ingenuity. So that's a good place to be. That's the right place to be limited, as opposed to struggling with things like builds and tests. And then this is just for HEC-HMS, this is just a listing of our versions since we started implementing. Well, we implemented prior to this, but since we really started doing Agile project management and CICD since version 4.4. And you can see some of the release dates, the duration from 4.3 to 4.4 was 526 days. So that was our last traditional waterfall release, 17 features, 16 bug fixes. And then you see since then the releases that have come out are a lot lighter weight and the duration between them is a lot shorter. And I think the beautiful thing is that we are delivering these small incremental releases with features to new customers. So the customers are just realizing these features much sooner than they would have otherwise. So I'll say that I'm coming from the HMS world, and I know Chris has said as much in part of the impetus of this presentation. If you've tuned into HMS in the past, you've probably seen these slides, but if you're in tune with other pieces of HEC software, you may not have noticed this yet, but you definitely will in the not too distant future. Because, like I said, nearly every team's on that steep part of the curve where they're implementing these CICD approaches to be able to better deliver software.
Okay, well, thanks, Tom. I'm going to grab the slides for a couple and then send it back to Tom again. So the fundamental change at HEC is much greater than just software development. And Tom talked mostly about software, but in order for us to release software, we have to have proper documentation to go with it. Therefore, we reviewed and revised our entire software and documentation process to make sure we deliver quality products, not just software, but documentation as well, without slowing down the pace of the development and delivery. There's no point in releasing software quickly and then having the documentation lag behind. So here are some of the types of reviews that are performed on every piece of software or any publication that HEC produces. We do peer reviews. I think it's pretty self-explanatory what a peer review is. The division chief then does quality assurance of the peer review. Sometimes the division chief can perform the peer review as well as a division chief review. Then sometimes we send it out for field review for the purpose to incorporate your feedback, which obviously can improve the product. We do cross-divisional reviews at HEC for the purpose to ensure quality and also share knowledge within HEC. And then everything comes to me eventually. And so there's a director review where I perform a quality assurance type of role, and it's for me for awareness, so I can talk to you about things like today. But my review can be anywhere from just checking to see that the quality control and quality assurance process has been performed to reading the entire document and doing an in-depth review. In order to deliver the best technical assistance and support, so remember there's the software development, but there's also the support that goes with it. And so in order to deliver the best technical assistance and support and get products and services to you faster, we've revised our documentation process, and Tom talked about it. It's sitting on Confluence. So if you have an issue, you see something, a figure's mislabeled or not labeled, or there's some confusion, we can go in, immediately change that, and then that change is then available to everybody. We don't have to wait 3 months for a documentation review process or something to get fixed. And so you can find all of our software documentation, such as user manuals, technical reference manuals, etc., online. You can find much of our training materials online as well. And you can ask questions about our software through the use of discourse. So just throw a question out in discourse, and then we can respond to that, or other people can respond to that as well. And this is all in an effort to provide services and support more quickly for us to be more nimble in how we address support. So really, that's kind of the end of our DevOps portion of this presentation. And this kind of let me sum up. We are moving to this approach to deliver better quality products to you more quickly. That's our motivation. That's what we're trying to do. And we understand we're pushing products at a relatively fast pace. We do. But it's important to know that you don't have to immediately upload and use the newest version. If the current version has a bug that's going to limit your ability to get the job done, then you'd want to upgrade as soon as possible. And each upgrade is backward compatible, unless, of course, the newest version is fixing a bug, then you should expect a different result. And finally, it doesn't appear that ACIT has been enforcing their N1 or their N and N1 rules, so there doesn't appear to be a problem with having multiple versions of software on your machine. We went out and did a scan, and there's all sorts of versions on all sorts of people's machines. So if there are any questions regarding CICD approach, we can address them at the end of this presentation, or you can dial in later with a question. And so with that, typically I would just take off and go and do a bunch of software updates. But since Tom is the lead of software lead, developer lead for HMS, thought it best that he just talk about the HMS slide. So there's a couple of HMS slides, and then we'll continue with some other software as well. So take it away, Tom.
Sure. All right, so we'll start with HMS. It's the industry standard for hydrologic modeling, and I think it's the industry standard both because of what you, the practitioners in the field, do with the software day in and day out, and then the enhancements that we're able to make. So that's impressive, and it's cool to be a part of, both from your perspective and mine. 100,000 downloads last year, that's a no small amount, and that was a huge bump from years past. I think because of all of these new features we've been rapidly deploying and getting out, I think it's created a lot of buzz around the software. And if you're not familiar with HMS, we're just computing stream flow throughout a river basin, given precipitation and watershed characteristics. So it's traditionally called a precipitation runoff model. We have one of the cool features that I don't think is highlighted in these slides, but is worth mentioning. We're actually doing the 2D hydraulic solution now on the land surface because that's been a high demand feature. So that's in there as well. So we're doing traditional hydrology and incorporating some hydraulic approaches within the model. And then there's some notes there about water quality and sediment and temperature. Those are ongoing R&D work unit efforts. One of the big noteworthy things of the past year was the GIS delineation tools, which were released in version 4.4, which I would be tempted to say that that's old news by now, but it actually just received a update and a revamp. So this is actually a simulation. I don't see it playing, Chris, but that's okay. I can just, oh, there we go. Okay, so.
Just waiting for you, Tom.
Oh, okay, the queue, yeah. So one of the cool things that was recently added to merging, you'll see here multiple subbasins being selected, and now we're going to see GIS merge. So that wasn't available in previous versions, but now you can do that. You can select multiple elements and merge them. Previously it was limited to just 2. And I will say that as of last night, hot off the press, there's a new split functionality that's a lot more robust than what was there before. So you can actually split from anywhere in the subbasin. It's not just limited to the identified streams layer. So that's kind of the detailed description, but the more general description is the GIS capability is available and is strong, and we actually formally decommissioned GeoHMS on the HEC website not too long ago. So now the recommended approach is to do it all in HMS. This is another cool feature we added recently, temperature, well, this is an illustration of temperature index SNOWMELT, but the concept is spatial results. So now you have the ability to view results spatially in HEC-HMS. So this is actually SWE over the course of a water year. You can see on the high elevations, the snowpack, how it gets dense and then comes down at the end of the season. So that's available not only for SWE, but several other spatial variables. And then another thing we like to talk about is runtimes and how they keep coming down. You'll see this comparison was done by Mike Bartles between 4.3 and 4.4, which is quite a while ago now. So we actually have some funding to dig into this a little bit more this year, and it's this ongoing work effort to catalog over the course of our past couple of releases how much the run times have been coming down. So there is a downward trend, which is what we want to see. We're actually building performance into our testing. So I talked about testing for accuracy, testing for regression. Another thing we're going to start testing for is performance, so that whenever we do new builds, we can actually test whether the software is running as fast as it did previously, or comparing it to some benchmark number. So I think that'll be cool, and we'll have more cool graphics like this in the future that illustrate how the software is getting more performant.
Okay, so thanks, Tom. I'm going to take over for a while, and it's about 10:40 or so, I see a lot of questions in the chat, so I don't think we're going to get to all those, unfortunately, but maybe we can catalog and we can get them back, get back to you all at a later time. Let's just kind of go through a couple other pieces of software. The reservoir operations software, HEC-RESSIM, newest version that is released officially is 3.3. RESSIM is used for real-time operations and planning studies, and it simulates just reservoir operations throughout the river basin given stream flow, and the stream flow usually comes in from HMS for both the flow into the reservoir and the local flows downstream of the reservoir. I don't have a whole lot more on HEC-RESSIM, but I can tell you that they are doing quite a bit of work in RESSIM as well. RAS, I think most people are aware of what RAS is and what it does. So it's just a list of things here. It too, like HMS, is an industry standard. And so on May 28th of this year, just a couple weeks ago, the RAS team provided a waterfall release. If you remember Tom's slide a couple slides ago, what a waterfall release is, that included over 16 major new features. So it was a Herculean effort for sure. And under the continuous integration, continuous delivery approach, this might have been 16 individual releases of RAS. So you'd say, well, why would you do that? Well, you waited a long time for these 16 new features. If we did multiple releases, then you wouldn't have to have waited for as long for some of these features anyhow. So the RAS team is transitioning to the CICD approach, as are the other teams at HEC. But everything takes time, and that's why we have our goal out there of August 2022. So some cool things. The RAS mapper has a raster calculator, so it can do comparisons of water surface elevation results or comparison of velocity results, all sorts of cool things from the RAS mapper thing. But a couple things I wanted to show you. One was this 3D visualization tool, and what you're going to see here is there's the interior area filling up after a levee breach has occurred, and then you can see the velocity vectors starting to show. And eventually we're going to zoom in, and kind of like you were in a helicopter, and we're going to zoom into the river itself, and then we're going to start going upstream and seeing what it looks like, seeing the terrain. And you say, is this kind of a cool, just funny thing that we're doing? Well, I think the important thing is visualization of results and helping decision makers, your local sponsors, understand what's going on. And so I think anytime we can do visualization, things like this, it's not just a pretty picture and it's not just a cool feature. It's actually very useful in helping people understand what's actually happening. Here we're going to turn around, we're going to go back to the levee breach, and again we're going to pop on the velocity vectors so you can see the flow streams and you can see where the water is going. And again, I think you can tell people about water surface elevation and things like that, and that's great. But if you can show them things like this, I think it's a whole lot better, and it's a whole lot easier for decision makers to understand. Mud and debris flow is introduced in 6.0, and this is something that Stan Gibson and a few other folks, Alex Sanchez, have been working on, non-Newtonian flows. And the key here is that mud and debris flows do not flow like water. And so what they showed here, this is actually a mine tailings dam in Brazil. And I'm going to show you two figures or two videos. The first one, this is going to play, and so the dam is right there. The dam actually fails, and this is the mud and debris flow going down. And what we found out is that the mud and debris flow capability does a much better job than just clear water approach of actual arrival times, extent, and depth. And so while that graphic is pretty cool, this graphic is phenomenal. And so this is the dam, and here's the dam actually failing. And then what we're going to see is there's all the mud and debris. It's going to be coming crashing down. I don't know the actual expanse of this thing, but it's pretty large. And then it's going to switch, and you're going to see the mud and debris flowing. And then it's in the quarry itself. There's a conveyor for the quarry. There's the mud and debris flow moving through. There you can see people, trains, everything trying to get out of the way. And so it's a clear example of why we do what we do and the benefits of doing these types of things. If we can show what would happen at a mine tailings dam or anywhere like wildfire, post-wildfire, where they have a lot of mud and debris flows, this is the type of feature that we want to have available to us to study those types of things. Computational speed, RAS team, in order to provide better, faster products, they too are increasing the speed of HEC-RAS. And so there you can see some of the speed factor increases between RAS 507 and 6.0. And so, I mean, your average is a 50% increase in speeds running RAS. And when you factor in the fact that we've done in previous versions many speed enhancements, this is pretty incredible that they were still able to get this kind of speed improvements out of RAS 6.0. Let's switch to FDA. Some of you don't know what FDA is, but it's the primary tool by the Corps for plan evaluation, plan formulation. Helps to answer our questions about which proposed flood risk management project is best from an economic perspective. And we're doing a lot of really cool stuff with it too. 1.4.2 is the current version on our website. 1.4.3 is being evaluated right now by the planning community to see if it can be planning COP certified. And as soon as it gets that certification, then we will post it as well. And then version 2.0 is right around the corner. And what I want to show you about version 2.0 is that we're doing a lot of cool things with the graphics. So 2.0 is under development. It's relatively close to completion. And the code base has been completely rewritten to support a modern approach to risk assessment and improve the stability of the software. FDA 2.0 is designed to take advantage of two significant advances in flood risk management over the last 20 years or so. And those are geospatial data, including structure inventories, and 2D hydraulic modeling. So these advances both greatly improve the quality of the data used on flood risk management studies. And FDA 2.0 integrates the geospatial functionality into the assessment of flood risk. Just like HMS and RAS, a user can now handle geospatial tasks directly out of FDA, and you don't have to go out to a third-party GIS software to carry out a lot of the required tedious pre-processing of geospatial data. So those are two of the big things that are happening with FDA. The purpose of this slide is to say that visualization of data helps quickly identify any busts or anomalies in the data. So what we were finding is that most of the problems with FDA in previous versions were bad input and just putting it incorrectly. And so now we have tools to visualize the input, and you can very quickly narrow in on where the bad data might be and then make those corrections. So it's a great benefit to have these visualization tools built directly into FDA instead of having to go out to Excel or something like that. And the third thing is that more graphics, just like I was showing RAS and the 3D viewer and helping people understand the results of the software, here, as results of the analysis, here's the same thing. We're trying to provide more visualization of output results to support the ongoing challenge of considering more than just the mean in decision making, so your expected annual damage. We're also looking at the distribution about that expected annual damage, and how do you make decisions differently? And the graphics like this help you to do that. Switching over to FIA, if you're familiar with FIA, it's another flood damage and consequence analysis piece of software. And it computes damages and life loss. It's used for emergency management operations and annual report to Congress. We've done a lot of work. Primarily, the focus has been on flood damages reduced. And so, in flood damages reduced, we use that along with the SWMS forecasts. We can also use 2D RAS output. And the flood damages are computed without levee using water surface elevation information. There's improved error checking. And we've been working with the Mapping Modeling Consequence Center of Expertise and their flood damages reduced team. And they're helping districts transition from the old way of using FIA to the new way of using FIA. And they're helping us provide support, documentation, training, and enhancements. So we can't do this all on our own. We're reaching out to players in your district offices, to the MMC and others to help us get a lot of this work done. And so here's kind of the new flood damage reduction methodology. What you see in the pink is the regulated flows, and then what you see in the blue are the unregulated flows, and then the dollars are just signifying dollar damages. And then in the levied areas, the structures themselves will get wet eventually, and when they do get wet, we tie that water surface elevation in the stream to the structure location, and that's what we're using in order to develop the depths at the structures to help us compute the damages at the interior areas to the levee. And so this is giving us structure by structure damages, so we can essentially compute an EAD, or expected annual damage, structure by structure, something we couldn't do before. So the benefits over this legacy method is that we can use our best geospatial data, we can use up-to-date structure inventory data, we can visualize how the event unfolds, tell that story so we can show people what it looks like, we can scrutinize each piece of information for the equation of the dollar damages, and we can then report our dollar damages back and our damages reduced to the reservoirs and to the levees, so we can allocate those benefits back to those projects and report that to in our report to Congress every year. So big changes there. I tend to miss EFM, the Ecosystems Functions Model, when I talk a lot of times, but I don't want to do that. I mean, essentially what the EFM is, if you're not familiar with it, is a tool that uses H&H and other metrics as surrogates to for environmental change. So the environmental changes are influenced by changes in flows, such as through operational changes in reservoirs or planning changes. If you do levee setbacks or things like that, you can use the EFM to see how those changes in your flow regime impact the environment. And so this is just an example of where we were using it with RAS 2D, and we are using it to evaluate different alternatives and their influences on salmon habitat. SWMS and RTS, yep, they're moving the CICD environment as well. The table shows you how quickly they went from 3.1.1 to 3.2.1, and now 3.2.2 was just released in April. We're already talking about a 3.2.3 release, maybe in September, and maybe a 3.3 release in the end of December or early spring. So we are automating the processes, not just in HMS, but in all of our pieces of software, and that translates into improvements and delivering products more quickly in SWMS and the WAT and tools like that. And so we have these more frequent official releases, and the carrot is to encourage the community to keep up with the software improvements, but the stick is we have to release faster or versions more quickly to maintain compliance with security requirements that the G6 has passed on as well. So it's kind of a double-edged sword. We want to get improvements to you, but sometimes we have to get improvements to you because to comply with the security requirements. SWIM, so, why is this important? Well, I think I've seen this slide many times before. I've used it for a long time, but look at this. We're getting greener and greener every time I show it. So there's 201 basins out there where SWIMS is being implemented. That's 76% of the country, if you're talking about the continental U.S., will be modeled with SWIMS models. So that means you'll have hydraulics models, hydrology models, reservoir models, consequence models for this entire area. And if new features are delivered more frequently, you have to assume that this will be good for your water resource projects that you will be building if you build off of the SWIMS models. So there's lots of opportunities. SWIMS is kind of the key hub for a lot of the modeling that I envision the HH&C COP will do. It will support dam safety, levee safety, planning, and all the other missions that you see around this particular kind of wagon wheel look. The WAT is also moving towards a CICD approach. 1.1 is nearing completion. It'd be web-based help to improve responsiveness and support like we showed on the HMS material. There'll be a plugin marketplace to update your plugins so that you'll be able to update them or build them and implement them within the WAT more quickly. You'll have an improved user experience for a number of different reasons. And any questions, concerns you have will be supported through discourse, just like HMS and just like the other pieces of software. So the WAT applications, it's building. The very bottom two are of interest. We've worked with the Nuclear Regulatory Commission, and we're developing a pilot with them. And if they're satisfied with that pilot, they may use the WAT to evaluate the risk to all of their nuclear power plants. And then FEMA, just had a call with FEMA yesterday. They're looking at redoing the flood insurance rate maps for the entire country. And how would they do that? They're interested in looking at the WAT and producing producing new risk maps using a WAT-like instance where we can get probabilistic flood insurance rate maps for the entire country. It would be a huge, huge effort, and FEMA and the Corps, National Weather Service, USGS would all collaborate on this probably multi-year effort to develop these new flood insurance rate maps. And I knew I blew through that really quickly, but I see we're getting close to being time's up. So summary, HEC is using CICD approach. It is new. It's got a lot of really cool things about it. We are continuing to develop a modern suite of H&H engineering, water resources planning, and ecosystem models. And our products continue to be public domain. They're online, free to download, along with not just our software, but our hydraulics manuals, our technical reference manuals, our training information, and even our support through discourse can all be seen online. And with that, I think that is the whirlwind tour through HEC. So, Sean, back to you. I know we don't have a lot of time, and I apologize for that.
No, I appreciate that. Thanks, Tom. Thanks, Chris. That's a lot of information to get into such a short period of time. And I know each one of those topics could be a webinar in and of itself, and that's something we might be looking to do in the future, but we'll spread those out. Thanks to Tom and Matt. If anybody was following along in the chat, there was a lot of great questions that were being put out there. Unfortunately, we didn't have enough time to answer them verbally, but between Tom and Matt McPherson, they were able to go through and answer all of the questions of the folks that of all the questions that folks had placed in the chat feature. I just had a couple others that I wanted to roll out there real quickly while we have a few minutes. So when Tom talked a lot about bug fixes or new releases and things of that nature, so what is the standard notification protocol for end users, either when a new release is made or when a bug fix is made to a particular version of software?
Yeah, that's a great question. And that's something we kind of wrestled with as we move to more frequent releases. I like the solution we're on now. It could potentially get even better in the future. What we've done in the past, the notification mechanism was just release notes. And, hey, we put this release notes, and unless you're tuned into the HEC website and our release notes, you may or may not see that. But what we've done with, at least the HMS team, we have an email list that we've built that for people that can subscribe at will or unsubscribe at will to get email notifications, which is great. But another thing that I really like that we've done is in-app notifications. So if you've been using the past couple beta versions of HMS, it will actually give you a dialog or a pop-up that says there's a new beta version or a new release version with all of these great new features. Download it here, and there's also a button that says, I want to completely ignore this, don't show it to me again. So, like I said, we've wrestled with that initially, acknowledging that these things are coming out faster. How do we communicate that? And that's I think the in-app notification is going to be something that most of our users are familiar with in a world where, smartphones and other things are telling users about updates that are available.